Okay, we're going to be in page 7 of your notes today, but before we get started, I want to do something. You can just write it at the top of your paper. So I want you to write x squared times x to the third. Now what we're going to do is we're going to rewrite x squared as x times x. We still have times, and then we have x times x times x as that x to the third power. So if we were to then rewrite this with an exponent, we would have x 5 times, so we have x to the fifth, and notice this 5, that exponent, is our two exponents added together. Okay, so our product rule says that when we have powers with like bases, so remember those are the big numbers, we add the exponents. Sorry if you can hear Baxter whining. Okay, so what this would look like is if I have a to the m and a to the n, these have like bases because they both have a base of a, and so we would have a to the m plus n. Give you a second to write that down. Okay, so examples. Again, both bases are a, and since we are multiplying like bases, we're going to add those exponents, so add 4 and negative 2, and that gives us positive 2. Here are like bases. We both have a base of x, so we can add together the exponents. Negative 3 plus negative 2 gives you negative 5, and like we talked about yesterday, we cannot leave a negative in the exponent, so what that's going to do is turn that into a fraction, bring the x down. Once that x comes down, that exponent is now positive 5. Don't leave the numerator blank. So 1 over x to the fifth. Okay, like base again, our base is 2. Add the exponents because we are multiplying like bases. Okay, so this asks us to simplify the product. So we have, again, like bases. When we have like bases and we are multiplying, we add those exponents because I'm going to have 2 3 times. Then I'm going to have 2 4 times. Well, if I have 3 times and 4 times, that's going to be 7 times. So 2 to the 7th power, and if you want, you can actually find 2 times 2 times 2 times 2 times 2 times 2 times 2, but we're just going to leave it like that for now. Okay, like bases again, our base is both 5 on these. We're multiplying, so we're going to add the exponents, so 7 plus negative 4 gives you 3. Again, you can do 5 times 5 times 5. We're just going to leave it like that because we're just practicing adding those exponents. Okay, like base, add the exponents. Negative 3 plus 3 gives you 0. We know from Wednesday that when we have anything to the 0 power, it's 1. So your answer on number 3 is just 1. Okay, now we are multiplying 5d to the 4th power times 8d to the 6th power. So when we have these big numbers, these coefficients in front like this, we're still just multiplying those coefficients. Okay, we're still going to take 5 times 8 and get 40. Then we look at our variables. The variables are both d, so we have like bases. And we're going to go ahead and add those exponents because our like bases are being multiplied. So we have 40 and then d to the 10th power. Okay, again, we're going to start by multiplying our coefficients. So negative 5 times 4 gives you 20. Then we have our like bases of g, and we're going to add those exponents. So we get negative 1. We don't want to leave that negative in the problem, so let's make a fraction. The only thing that's being raised to the negative power is the g, so that's the only thing that moves down, which means the 20 stays up top. Now you can put g to the 1st power, or you can just put g. Okay, this is future me coming in to say I messed up and you should have negative 20 because negative 5 times 4 is definitely negative 20. So make sure you have negative 20 in your numerator, not regular 20. Okay, start by multiplying our coefficients. We get -6. All right, I'm going to start by identifying my like bases. So I can combine my a's. So I have a. Then I'm going to do 2. The imaginary exponent on my second a is 1. So I can add the exponents on the a's together and get 3. Then my b's are like bases. So I have a b. I'm going to add those exponents and get 6. My c's, imaginary exponent is 1. 1 plus 0 is 1. So this is your final answer. Okay, make sure you are only adding exponents with like bases. So you're not going to add the exponents of the a and b, right? We're not adding these together. You're adding the like bases only. Okay, like bases. Last problem. In front of that a is a -1. Here we have a -4. So -1 times -4 is 4. Here's an a, here's an a. Add those exponents together and we get -1. Here's a b, here's a b. Add those exponents together, -1. Okay, we can't leave our negative in our exponents, so we're going to look here. The a is being raised to a negative power and the b is getting raised to a negative power. The 4 is not, so the 4 stays on top and the a and b go to the bottom. Okay, now you can write a to the first power and b to the first power, but you don't have to. Okay, and so that is your product rule. So now you are going to work on the practice problems in your packet and email me with any questions.